All right, let's jump right in. For so long, we've thought of AI as, well, basically a brain in a jar, right? A ghost in the machine. But that's all about to change. Today, we're talking about something way bigger. We're talking about the automation of reality. This is the story of what happens when AI finally gets a body. For decades, AI has lived entirely behind a screen. It's been learning, thinking, talking, but only in the digital world. It's been locked in a box. So the big question is, what happens when it finally breaks out? I mean, really breaks out. What happens when that intelligence can suddenly reach out and touch, move, and change the physical world we all live in? Okay, to really get a handle on this, you gotta understand this old school split. Think of it like this. On one side, you've got software intelligence. That's the brain. It thinks in code, in tokens, abstract stuff. It has no real connection to the physical world. It's not grounded, as they say. Then, on the other side, you have embodied intelligence. That's the body. It's all about physical actions, actually doing things in the real world. For forever, really, these two worlds, the AI brain and the robot body, were completely separate. They were on different tracks. Well, not anymore. And that collision of worlds brings us to what's being called the convergence moment. And let me tell you, this is not just some incremental update. This is the main event. It's AI breaking out of that digital box, and this time, it's for good. So what does that actually mean, the convergence moment? Well, it's the point of no return. It's when that old wall between the digital brain and the physical machine just dissolves. It's the moment when our machines go from being simple tools that we use to becoming agents that act on their own. Here's the best way to think about it. It's the difference between a robot on an assembly line, right? It just follows a simple, repetitive script over and over. It has no idea what it's even doing. That's one thing. But then you have a robot that actually understands its environment. It can see, react, and make decisions. You see the difference? One is a DEM tool, the other is a thinking, acting agent. Okay, I know what you're thinking. This all sounds a little bit like science fiction, right? So the big question is, why is this happening now? What's the secret sauce? Let's take a look under the hood at the engine driving this whole new reality. So it's not just one thing. It's more like a perfect storm of four massive technologies all hitting their stride at the exact same time. First, you've got insane high-density compute. Think NVIDIA's chips. Then you've got multimodal sensing, which is just a fancy way of saying robots can see, hear, and even touch. Third, there's internet-scale data, a nearly infinite library for these things to learn from. And finally, and this is a big one, we're getting way better at high-discharge energy to actually power these machines. All right, let's get real for a second and break down where we actually are with this stuff. The AI models, the brains, are getting incredible. They can think on the fly while moving. That's huge. The sensors are getting better, but we're not quite there yet. We still need something like a sensitive skin for robots to do delicate jobs. But you know what the biggest bottleneck is? Energy, plain and simple. A robot that only runs for 2 hours isn't much use in a factory that runs an 8-hour shift. Solving that battery problem, that is absolutely key. So once the tech gets there, and it is getting there, we hit the next phase. Because let's be honest, this isn't just a cool science project. At its core, this is an economic revolution. We are literally talking about rewiring the physical world, and it all hinges on one incredibly powerful tipping point. And here it is. This is the number that changes everything. Between $2 and $10 an hour. That's the all-in estimated cost for a humanoid robot to do a job. We're talking the cost of the machine, the power, the maintenance, the whole shebang. Just let that sink in for a moment. $2 to $10 an hour. And when you see the trend lines, the economic logic is just undeniable. Human labor costs, they keep going up. The cost of robot labor, it's in free fall. And that gap between the two lines is getting wider every single day. That's not just an incentive, it's a massive gravitational pull. For any business trying to compete, this stops being a choice and starts becoming a necessity for survival. Now, this whole wave of automation isn't going to hit every part of our lives at the same time. Think of it like a rollout. In the very near future, like through 2028, the action is all in highly structured places. Think warehouses, logistics, maybe some defense applications. But the long-term vision, we're talking 2050 and beyond. That's when we could see general-purpose robots right in our own homes, maybe even as companions. So yeah, this isn't an overnight flip of a switch. It's going to happen in stages. Phase 1, by around 2028, is all about narrow autonomy at scale. Basically, robots doing specific jobs, mostly in warehouses. Then, fast forward to 2040. That's when we might see general-purpose robots in more public but still controlled spaces. But 2055? Wow. That's the potential date when these systems could truly, fundamentally reshape, well, everything, civilization as we know it. And that right there, that brings us to the really big stuff. The questions that go way beyond tech and economics. We're talking about a massive choice for humanity itself. How do we want to structure our society? What happens to work? And who holds the power in this new world? Because, let's be real, in a shift this huge, there are going to be winners and losers. The big winners? Probably the companies orchestrating the whole thing, like Nvidia and Tesla, and any country that happens to control the critical resources. And the losers? Well, it could be tough for people in jobs with repetitive physical tasks, but also, surprisingly, some middle-skill office jobs. They're calling it a K-shaped transition, where one line goes up and the other goes down. Some fortunes will skyrocket, while others could plummet. This also throws a huge wrench into geopolitics. Just look at this number. Right now, in 2024, China controls 95% of the world's high-performance magnets. 95%! These are basically the muscles inside every advanced robot. This isn't just some boring supply chain problem. This is a massive issue of national security and who holds the cards for the future. So, when you put it all together, it feels like we're standing at a giant fork in the road, a real civilizational choice. Down one path, you can imagine a future of political turmoil, where all this new wealth gets concentrated at the very top and society kind of fractures. But down the other path, there's a scenario where the benefits are shared more widely, freeing people from just working to survive and allowing them to chase bigger ideas, purpose, creativity. And that really frames the ultimate challenge ahead of us. There's a quote from the source material that just nails it. The challenge for the next generation is not to compete with this intelligence, but to provide the meaning and purpose that it serves. You see, our job isn't to do the work anymore, it's to decide what work is worth doing. Which leaves us with one last big question to chew on. As we build a world where machines can flawlessly handle the how of everything, how to build something, how to transport it, how to fix it, the real question becomes, who defines our why? Why are we doing any of this in the first place? And that, really, is the question that all of us are going to have to answer.